Hello everyone, I am Rakshita studying MTech CSC at Bangalore Institute of Technology. Today I am presenting case study with Python program and Django framework on smart grid. Agenda. In this presentation I will explain what smart grid is, why it is important, the problems in traditional grids, objectives, key features of smart grid, hardware and software components, architecture, working, how Python and Django are used. A case study on smart energy consumption monitoring, code snippets and output, then finally the results and conclusion, then future enhancement. Next, introduction to smart grid. A smart grid is an advanced electricity network that uses smart meters, sensors and communication system to monitor and control electricity flow in real time. Unlike traditional power grids, smart grids support two-way communication between electricity providers and consumers. This means electricity usage can be monitored instantly, faults can be detected quickly, the power can be managed efficiently. The main goal of the smart grid is to provide a stable power supply, reduces losses and support renewable energy resources like solar and wind. Importance of smart grid. Smart grids are important because they improve efficiency and reliability of electricity system. They enable real-time monitoring which helps in identifying faults quickly and reducing power outages. Smart grids also reduce power loss and electricity theft by continuously analyzing data from smart meters. Another major advantage is the integration of renewable energy sources. Consumers also benefit from accurate billing and better understanding of their energy usage. Next is problem statement. Traditional power grids suffer from many limitations. They operate with one-way communication. That means consumers cannot send feedback to the electricity provider. There is no real-time monitoring which makes fault detection slow. Power losses during transmissions are high and electricity theft is difficult to detect. Manual billing systems are time consuming and error prone due to poor load management. Power outages occur frequently during peak hours. Next one is objectives. The main objective of this is to monitor electricity consumption is in real time using smart meters. The aim to analyze energy usage efficiently using Python programs. It also focuses on detecting abnormal power consumption and reducing energy losses. Another objective is to provide a web-based monitoring system using Django framework. Overall, the goal is to improve load management and support sustainable energy usage and support efficient and sustainable energy management. Next is key features of smart grid. Smart grid has several key features. First is two-way communication between consumers and utility provider that enables better control, feedback and energy management. Second is real-time monitoring which improves energy reliability. Third is smart metering which ensures accurate billing and transparency. The smart grid also supports renewable energy integration. Finally, automated load management helps balance electricity demand during peak hours. Next one is Hardware components of smart grid. These components are responsible for collecting, transmitting and controlling electricity data. First is smart meters. Smart meters are installed at consumer locations. They measure electricity consumption in real time and automatically send usage data to utility provider. This helps in accurate billing and continuous monitoring without manual meter reading. Second one is sensors. Sensors are used throughout the power grid to detect parameters like voltage, current, temperature and faults. They help in real-time system monitoring and enable quick fault detection which reduces power outage. Next, the third, data concentrator unit, also called DCU. The DCU collects data from multiple smart meters in a particular area. It acts as an intermediate device and forwards the collected data to central control system for further analysis. Fourth is communication devices. Communication devices are used to transmit data between different grid components. Technologies such as GSM, RF and IoT internets are used to ensure fast and reliable data transfer. Finally, control and protection devices. These devices automatically controls switches and circuit breakers. When fault occurs, they isolate the affected area and maintain sustainability, overall grid stability and safety. All these hardware components work together to make the smart grid reliable and efficient. Software components of smart grid. Data processing software. This software processes electricity usage data collected from smart meters. It analyzes the data to identify consumption pattern, peak usage and abnormal behavior. This helps in reducing energy loss and improving decision making. Energy Management System, also called as EMS. The EMS controls and optimizes power generation and distribution. It helps in balancing load during peak hours and improves overall grid efficiency. This system plays a key role in reliable power supply. Database Management System. Database stores the consumer details, smart meters reading, billing information and historical energy data. It ensures secure storage and easy retrieval of data whenever required. Then application using Django framework. The Django web application provides a user-friendly interface for both consumers and administrators. User can monitor energy usage, view reports and receive alerts. Administrators can manage users and analyze system performance. These software components make smart grid system interactive and efficient. Next is system architecture. In this system, smart meters are installed at consumer location. These meters collect electricity usage data and send it to central server. Python programs process the data to collect daily consumption and detect abnormalities. The processed data is stored securely in database. The Django web application displays graphs, report and alerts for users and administrators. Next, this diagram shows the smart grid architecture. It has three layers. Power system layer, electricity is generated, transmitted through high voltage lines, distributed through transformers and finally consumed by homes and industries. Communication layer. This layer sends data between smart meter, substations and control system using AN, NAN and WAN through fiber optic. Application layer. This is the control center. It monitors power usage, manages demand, detect faults and control the grid efficiently. Next, working of the smart grid system. It data collection, data transmission, data processing, data storage, monitoring and visualization. In data collection, smart meter collects real-time electricity consumption data from users. Data transmission. The collected data is sent to central server through communication network. Data processing. Python programs analyze the data to calculate energy usage and detect any abnormalities. Data storage. The processed data is stored securely in a database for future reference. Monitoring and visualization. The Django web application displays reports, graphs and alert for users and administrators. Next one is role of Python and Django. Python is used for processing energy data, collecting daily and monthly usage and identifying peak hours. It also helps in detecting unusual consumption patterns. Django is used to build the web application. It provides user authentication, dashboards and visualization of usage energy. Together, Python and Django enable real-time monitoring and scalability. Case study overview. This case study focuses on smart energy consumption monitoring. Smart meters collect hourly electricity usage data. Python processes this data to calculate total consumption and peak hours. Django provides a web dashboard for users and administrators. Users track real-time usage and administrators monitor grid performance. This system helps reduce energy wastage and improve efficiency. Case study on smart energy monitoring. Many users are unaware of their real-time energy usage, which leads to wastage. In this case study, smart meters collect energy data and Python analyzes it. Django provides a dashboard where users can view daily and monthly consumptions. This helps consumer understand user patterns and reduce unnecessary power consumption. Code snippets. Python code smart meter logic. This Python class represents a smart meter. It takes electricity reading as input. This daily usage calculates the total energy used in a day. This peak hours finds the time when electricity usage is highest. So Python analyzes the consumption data. Django model. This is database. This model stores electricity data in database. Each reading belongs to a user. It stores time and energy consumed in kilowatt. So this part saves the smart meter data permanently. Django view, processing and display. This function creates the dashboard. It takes the user's reading from database, then sends them to the Python smart meter class, calculates the total usage and peak hours, sends results to web page. So this connects database analysis, and website. The system collects energy data, then stores in database, then analyzes using Python, then display results on Django web dashboard. Output. This is the user dashboard of our smart energy monitoring system. It welcomes the logged in user. It shows daily energy consumption. Here it is 32.2 kilowatt. It also displays peak hours, which means the time when electricity usage is highest. 7, 8, 17, 18 hours. Below that we show hourly readings. Each hour's electricity usage is listed in kilowatt. This helps the user to understand when they are using more power. Using this information, users can reduce usage during peak hours and save electricity and cost. Result and analysis. The system successfully collected hourly energy data. Daily consumption and peak hours were calculated accurately. Users could clearly see their energy usage patterns. Monthly reports were generated automatically. Then, this reduced manual effort and improved energy awareness. Finally, the conclusion. In conclusion, this demonstrates an efficient smart grid system using Python and Django. It enables real-time monitoring, reduces energy wastage, and improves grid efficiency. This system is scalable and sustainable and suitable for modern energy management needs. Future enhancement. In the future, machine learning can be used to predict energy consumption. Mobile app notification can be added for real-time alerts. Next, renewable energy integration and automated billing can further improve the system. Thank you.